Now let us design a bus system. You know that the bus system is a transportation medium in between CPU and the other devices that are needed to be communicated, that are needed to transport the data. Okay, here there are primarily two things that are needed to be connected. One is main memory and one more is peripheral devices. Okay, here I do have a main memory that is needed to be connected by the bus system. And the second one is peripheral devices. Let us say these are the interfaces. Interface 1, interface 2, interface 3, and interface 4. Each of these interfaces are connected to one of the peripheral devices, let us say. Okay, now let us design the bus system. You know that the bus system has three lines. One is address line. Second one is data line. And the third one is control line. Okay, address bus, data bus, control bus. The bus system comprises of these three: address, data, and control. Now, this bus system can be designed and organized in three different ways. Let us examine what are those. The first one is distinct I/O. The second one is isolated I/O. And the third one is memory mapped I/O. Memory mapped I/O. Let us understand what are these three different things. In the distinct I/O, we use separate bus systems. That is, a separate bus system, that is, separate address line, separate data line, and separate control line for main memory, and one more address, data, and control line for peripheral devices. Okay, that is, we do use two separate bus systems. There are two separate bus systems in order to communicate with the main memory as well as the peripheral devices. But here try to understand, if you want to implement this technique, you do require a separate processor. You know that the CPU is the main processor, but if you want to establish a distinct I/O bus, that is two separate buses, one is for main memory and one more is for the peripheral devices, you do require to have a separate processor which is called I/O processor. Okay, where the main processor will take care of the transformation in between, the information transfer in between main memory and the registers. This I/O processor will take care of the transfers in between the peripheral devices and the CPU. Okay, so if you want to implement distinct I/O, you require a separate processor. Okay, that how this distinct I/O works, let us see. Let us take that user is executing a program. Okay, user is executing a program. You know that in a program we can have three different kinds of instructions. One is memory reference, second one is register reference, and the third one is I/O instructions. These instructions are jumbled across the program. Whenever he needs to access the information from the main memory, that is the data operand from the main memory, memory reference instructions will be used. If the data operands are available in the registers, register reference instructions will be used. When the data operands are available in I/O devices, the I/O instructions such as INP and OUT will get used. Now, when a processor is executing a program, our regular processor, this is not a I/O processor, this is our regular processor. When this processor is executing any instruction, it is going to analyze what kind of an instruction it is. If it is memory reference instruction or a register reference instruction, it is going to execute on its own. But if it finds out an I/O instruction Then this processor is going to send this instruction to IO processor, because this is the main processor. Okay, this is CPU, let us say 8086. Okay, this is the IO processor. There is one IO processor which is called 8089. So the system has two processors, in which one is 8086, which is a regular processor. One more is 8089, which is an IO processor. IO processor will take care of IO transfers. Main processor will take care of the every other thing, including memory transfers. Okay. Now, every time when a program is being executed, all the memory reference instruction, register reference instruction makes a transfer in between main memory to memory, or register to register, or vice versa. The transfer will not go to the peripheral devices. Okay. But when an IO instruction gets executed, this is nothing but a peripheral device transfer to and from. So whenever this 8086 processor in the system is executing the instruction, and if it finds out that there is an IO instruction incoming, immediately it is going to send this IO instruction to 8089. Then this 8089 is going to collect this IO instruction and executes it. As a result, a transfer will get initiated to or from the peripheral device to the main memory. This is how the IO processor is going to separate the transfers of CPU as well as the peripheral devices. But for that, we do require a separate processor. So in a distinct IO, we use separate bus system. This is one set, and there will be one more set to communicate with peripheral devices. Address, data, and control. So we do have two different sets of bus system for having distinct IO implemented.